Okay, so 3.4, the second part of it is synthetic division. When we learned long division, I told you long division worked for any polynomials, and that's why we had to learn it. Synthetic division is quick, very quick, but it does not work for any polynomial. It only works for linear binomials. Synthetic division only works when you are dividing by, when your divisor is a linear binomial. Only. And some of your problems were not, your divisors weren't binomials, were they?
Most of them were.
Most of them were, but they weren't linear, were they? They were like x squared or...
So linear
So-
is when it doesn't have an x squared.
The exponent is 1. Linear, the x, it's power of 1.
We learned that.
So now if you have a trinomial that you could factor, then you could use synthetic division twice with the factors. But you can't with the trinomial. So what you do, so when we did long division, we took x minus 3 and we divided 2x cubed minus 7x squared plus 0x minus 4. You still have to fill in your holes, right? That's what we did. So when we do synthetic division, we take the factor and we set it equal to 0. So this 3 is x minus a equals 0. So x would equal a. Right? Because you'd add a over.
Yeah.
So we put, after we set the divisor equal to 0, we put it out here in a little box. I draw my box a little different. Where did the 2, negative 7, 0, negative 4 come from? What are those numbers called? Starts with the C.
Coefficient.
The coefficients. They're the coefficients. Okay, that's the setup. And then I'm going to show you how to do it because it's kind of weird. But again, when is the only time I can use this?
If it's like a linear binomial.
Okay, the what?
Leading coefficient.
Divisor.
The divisor. When the divisor is a linear polynomial, it's the only time you can use it. Okay? You still have to have everything in order. You still have to fill gaps. Okay? What? No, what do you need,
I
Sadie?
need to do the step 2 thing.
What are you writing of it?
The whole thing. Do I need to write that or no?
No.
Okay, I'm just going.
Because I think writing all the words is going to confuse you to what the actual process is. Does that make sense?
Yeah.
Okay. So if I need to go back, you let me know and I will. Okay, so what is my divisor? I have 2x cubed minus 7x squared plus 4 divided by x minus 3. So what's my divisor? X minus 3. So I set my divisor equal to 0. So x equals 3. I do my bar a little different. I just do this. I do it upside down division. Okay. My coefficients, are they in order? Do I have any gaps?
No. No. Yeah.
Yes. I'm missing an x to the first, right? So right in here, there'd be x or 0x to the first. So my coefficients are 2, negative 7, 0, negative 4. Everyone following? Do you notice the gap I have? Okay, we're going to write another row of numbers there. Wasn't straight. So the first step you do is you bring down that. Whatever that is, you bring it down every single time. So 2. Now I take 3 times 2 and it goes here. So 3 times 2. I normally will not write the 3 times 2. I'm just doing it this time so you can see. Okay? So 3 times 2 is 6. And combine. Negative 7 and 6. You get what? Negative 1. And then we come back up here and we take 3 times negative 1. Which is negative 3. Combine 0 and negative 3. Negative 3. Am I going too fast?
No.
Okay. Then what do you think this step's going to be?
3 times negative 3.
3 times negative 3 is negative 9,
So negative 13.
negative 13. Okay, so now I need to explain what this all means. So we did the synthetic division, it's over. We basically have an answer in front of us, we have to just rewrite it. So since I'm dividing by 1 power of x, linear, every single time, yes? This power up here goes down by 1. Goes down by 1. So what it means is 2x cubed minus 7x squared minus 4 equals the divisor, x minus 3, times, so this was cubed, this is squared. 2x squared minus x minus 3. Wait a second, we have an extra number. It's the remainder. So minus 13. This last box is always
The remainder.
the remainder. A lot quicker than long division, isn't it?
Yeah.
But can I use it all the time?
No.
No. Can I use long division all the time?
Yeah.
Yes.
It's really not that much different.
It's different.
Not really.
Synthetic division can be used for a lot of things. You know what's kind of neat about this? It's this remainder right here. The remainder theorem says if I plugged in 3 to this equation, I would get the remainder.
Yeah, let's not do that.
No, you are going to do it. So let's test it. So 3 into this equation, right? So 2 times 3 cubed minus 7, 3 squared minus 4. Now this isn't horrible, but do you see how this could get really bad to have to plug something in? So would synthetic division be a quick way to actually evaluate a number?
Yeah.
Yeah, you know what I forget to do all the time? Synthetic division. Okay, so this is 27 times 2, so that's what, 54? And then 9 times 7 minus 63 minus 4
13.
How does
is, so that would be 50 minus 63, which would be negative 13. So again, was the synthetic division easier to do than plugging it in? Yeah. Okay. So I have it written differently, but is it any different? Nope. What is my divisor?
1?
Well, my divisor is
X minus 1.
x minus 1, so I set it equal to 0, so x equals 1.
You're missing the x squared.
So 1. Okay, so is it in order, first of all?
It's in order.
It's in order, but I'm missing a x squared. So what are my coefficients then?
3x.
Not x, 3,
Oh, 0.
0,
0.
negative 5, 10. Do not put your numbers too close together. You need room to see separation, okay?
Okay.
If you don't, they're going to blend together and you're going to make a 1 and a 5, a 15, and life's going to be hard. Okay, what do I do first? Remember? Bring down the 3. And then?
There's a lot of zeros. And then you multiply 3 and 1.
1 times 3 is
3
3.
times 0.
Not times.
Oh, you add it?
Just combine it. So 3.
Okay.
And 1 times 3 is
3
3.
minus negative 2.
9, negative 2. 1 times negative 2.
Negative 2.
And so I get
8.
8.
And
So
X.
my answer would be x minus 1 times,
why are you writing? Okay.
because that's the divisor, 3x to the what?
Why didn't you put the divisor first last time?
Correct. She did.
I did.
But she rewrote the problem.
I rewrote the problem. I just didn't want to rewrite the problem.
Oh.
Okay, x to the what? Second. Why is it
Oh.
second?
So you just
Because it always subtract what? 1. And then
we do that.
plus,
So it's not 3x.
because you're dividing by a power of 1, so you're going to go down 1 degree. So it was cubed, so I go down to second. So plus 3x minus 2,
Remainder 8.
so plus 8. So if I multiplied these two and added 8, I better get what? That. So if I factored that, is x minus 1 a factor?
No.
No, because the remainder isn't what? Remember we've talked about that? 0?
Yeah.
Okay. Okay, so the remainder theorem is what we just said it was. The remainder theorem says if I plug in the number, if I plug in this a, I will get what the remainder is. That's what it says. I can use it to evaluate. On your test, it's going to say evaluate using the remainder theorem. That's exactly the directions it's going to say.
What does that mean, just to check?
Nope, it means to do synthetic division and your remainder is the answer. Okay? So if it says evaluate using the remainder theorem, then you do synthetic division. So I have x cubed plus 10x plus 29 plus 24, or 29x plus 24, divided by x plus 5. So what's my divisor? X plus 5. So what do I do with it? Set it equal to 0.
Your x equals -5.
So x equals -5. So -5 takes up much less room.
What do you call that line with the box, like half box?
I don't know.
The box.
An upside down division thing. I don't know.
The box.
A box. And you will see a lot in a lot of books. It will be like this. That little box around the 5 bugs me.
It bugs me.
Okay, so is my dividend in order? Gaps?
3, 2, 1, 0. Yeah.
Nope. So what are my coefficients?
1, 10, 29, and 24. Why don't you get it bigger?
You want to do it on your own?
Yeah.
Okay. Okay, did you get 4?
Yeah.
Yes? Okay, so you write it as P of -5 equals 4. So that means I already replaced all the x's with what? -5? And if I wanted to verify it, I'd put it in there, but I don't want to do -5 cubed plus 25 times 10 plus -5 times 29 plus 24. Do you?
No.
No. It's 4, so it should be plus and minus things. It should be pretty small, right? But I don't want to do it when it's huge. Do we need to do another one?
No.
No. Okay, so the remainder is what you get if you were to evaluate, yes?
Yeah.
Okay. So the next thing is the factor theorem. And we've already just talked about this one too, but I haven't given it a name. If the remainder is 0, then the divisor is a factor of the polynomial. So I'm going to put it in my words. So if the remainder is 0, the divisor is a factor of the dividend. Probably should say that, right? Use those words. So if the remainder is 0, it's a factor. We've talked about that, right? If I take 16 divided by 4, what's my remainder? 0. Is 4 a factor of 16?
Yeah.
Yes. If 16 divided by 5, what's your remainder? 1. So is 5 a factor of 16? No. The same thing. Same thing. Okay, so the question is x minus 5, or x minus 6, or in other words, x equals 6. So is x minus 6 a factor of x to the 4th minus 8x cubed plus 16x squared minus 23x minus 6? So what do I need to do?
Synthetic.
Synthetic division. So 6 is my dividend in order.
4, 3, 2,
Yes.
1, 0.
Gaps? No. So what are my coefficients?
1, negative 8, 16, negative 23, negative 6.
Okay, so do this one and the next one to make sure you got it. So we're doing the same math, just the results are telling us things. Things.
Wants to do the next one too?
Yes, please.
Hmm.
Why did I do that?
I thought 6. That ain't right.
No, that wasn't. And that isn't either. I need to quit talking while I'm right.
That's all you have to write. Yes. X minus 6 is a factor.
Mm-hmm. I mean, we will eventually do more things, but right now,
That's
yes.
how you write your answer.
Mm-hmm.
Is this all we have for this?
I don't know. There might be one more. So is x plus 3 a factor? No, because my remainder is negative 21. Now, we need to discuss this. So if I plug it in, I get the remainder. So that would tell me that, like, p of negative 3 would equal negative 21, right? And this would be p of 6 would equal 0. Well, if p of 6 equals 0, what is x equals 6? Isn't that an x-intercept? Yes. So this is going to lead us into factoring, yes, but graphing polynomials like this. So we're going to have to find the rest, and there's 4, so how many zeros at most are there? 4. So some could be imaginary, some could not. But we came down to x cubed, right? And we could factor that by grouping, maybe not. But if I got it down to x squared, I always can factor or use the quadratic formula, correct? So the goal is to get this down to something that you can factor to find the remainder of the zeros. So all this stuff is building to get us to to get us to graph these polynomials. And yes, that is it.